Now, if you remember multiplication of fractions from before, if you multiply fractions, all you have to do is multiply the numerators, multiply the denominators, and then factor. So we have 4 times 2 times 7 times 10. You can break it all the way down, or you can just break it down to some extent. So you can cancel all common factors. 4 times 10 is 40, and then times 3. Let's see what cancels. We have 10. The 7 goes. The 4's cancel. The 2's cancel, and you're left with a 1/3. Now, what if we had, for example, 55 over 27 divided by 22 over 18. And how is this done? We go 55 over 27 we change the division to multiplication, and what we flip is that only one fraction to the right. So that's 18 over 22. And now it's the same thing. It's multiplication of fractions. Break down into factors, which means factor the numbers. 9 times 2 is 18 over 9 times 3 is 27, and 11 times 2 is 22. Cancel common factors. Everything cancels. We're left with 5 in the numerator and 3 in the denominator. Now, the exact same process has to be followed in this situation, except that now you have algebraic expressions that you multiply and divide. So let's do the multiplication and division. So we have 4x cubed over 7y squared times 6z to the 5th over 5x to the 6th. Now let's change division to multiplication, which is a dot, and then flip the fraction. So now we have the 35x to the 6th in the numerator and the 24z to the 2nd in the denominator. So we have 4x cubed times 6z to the 5th times 35x to the 6th all over 7y squared times 5x to the 6th times 24z squared. Now we could combine the x's in the numerator. So we have, let's keep the numbers separate. 4 times 3 times 2, that is 6, times 7 times 5, that's 35. So what I've done is I've collected all these constants and factored them to some extent, times, I'm going to combine the x cubed with the x to the 6th. So x cubed times x to the 6th, when we apply the rules of exponents, it is 3 plus 6. So that is x to the 9th power. So we have x to the 9 times z to the 5th. So we combined all the x's, combined all the other numbers. In the denominator, we have 7 times 5 times 4 times 6 is 24, right? So we collected all these constants and wrote it down first. And then, of course, we have the y squared, x to the 6th, z squared. So that is, we'll cancel as much as we can. The 4's cancel. the 5's cancel. 3 times 2 is 6, cancels with the 6. So all the numbers are gone. It becomes a 1. So you have 1, and that's not an x. Let's use a dot because it shouldn't be confused with the x. Now we have x to the 9th times z to the 5th over, I'm just rearranging the terms, x to the 6th z squared y squared. These two can be combined by the rule of division of exponents. X to the 9 over x to the 6 is equal to x to the 9 minus 6, which is x cubed. Remember, the rule of exponents is what is being used here. So that's x cubed. Now we can combine z to the 5th and z squared and write it as z to the exponent of the numerator minus exponent of the denominator. Y cannot be simplified further, so we're going to leave it in the denominator. So that is x cubed times z to the 3rd power over y squared. So it is x cubed z cubed over y squared. So notice what we did on the right. When multiplying fractions, we factor the numerator, we factor the denominator, and then we cancel the common factors. So we have x squared minus 16. So x squared, 16 is a square, so we write it as 4 squared. So what we have is a difference of squares. And remember the special product, it's x plus 4 times x minus 4. X squared minus 25. Remember 25 is a square, which is 5 squared. Again, it's a difference of squares. X minus 5 times x plus 5. Now we write this down. We multiply the numerators and factor. So this is x plus 4 times x minus 4 times x minus 5 divided by x plus 5 times x minus 5 times x minus 4. So we factored the numerator completely, factored the denominator completely. Make sure you have parentheses. And now all we have to do is cancel common factors. Cancel the x plus 4, cancel the x minus 5, and we're left with x minus 4 over x minus 5. These are the only two factors left. One in the numerator, one in the denominator. Here again, we are multiplying fractions, something like multiplication of fractions. And this is a multiplication of rational expressions. Now, if something clearly cancels, then you don't have to factor anything. Now this one clearly, this entire factor cancels with this entire factor. Now let's see what we are left with. So there was no need to factor it because the whole expression cancelled. So that's easier. You don't even have to try to factor it. Now we need to see if by factoring the denominator, it is factorizable. We can cancel more common factors. We have x minus 1 in the numerator. Factor the 4 out. Make sure you're factoring it completely before you decide that it cannot be factored further. Notice what happens here. Once we factor the 4 out, we get x minus 1, which is a common factor in the numerator and denominator, and that's equal to 1 over 4. Let's try one more. Remember, this is division. what do we do when we have to divide fractions? We change division to multiplication and we flip the fraction on the right. So we have a squared plus 7a plus 12 divided by 5 minus a, so that's your rational expression. Now we change division to multiplication and we flip the one fraction to the right. So the rational expression to the right is flipped and we have a squared plus 9a plus 18. Now each of these has to be factored. So let's factor each of these expressions and then we'll put it all back together. Remember, we have to factor and then cancel common factors. So let's factor a squared plus 7a plus 12. The coefficient of a squared is 1. 1 times 12 is 12. 4 times 3 is 12. 4 plus 3 is the coefficient of the middle term, which is positive 7. So we write this as a squared plus 4a plus 3a, because 4a plus 3a is 7a plus 12. Next, we factor by grouping a plus 4 when we factor out the a. The common factor between 3a and 12 is 3, positive 3. So plus 3, a and 12 is 4 times 3, so you have a plus 4. This is equal to, the common factor is a plus 4. We factor that out and we are left with a plus 3. So it's times a plus 3. So we factored this expression, that's a plus 4 times a plus 3 times, next we're going to factor this expression, a squared minus 7a plus 10. The coefficient of a squared is 1. 10 times 1 is 10. We want the middle term or the sum of the factors to be the coefficient of the middle term, which is negative 7. So 5 times 2 is 10. However, 5 plus 2 is equal to 7, but that's not what we want. We need negative 7 and that's easy. So we go negative 5 times negative 2 is equal to positive 10, and negative 5 plus negative 2 is equal to negative 7, which is the middle term. So we use the factors to break down the middle term as 5a minus 2a minus 5a minus 2a is minus 7a plus 10. Common factor a minus 5 minus 2. Factor the negative 2 out because we want a minus 5 in parentheses. Factor out and you get a minus 2 times a minus 5. So this is a minus 2 times a minus 5. So I'm going to change this to a dot so we don't confuse it with an x. The whole is divided by 5 minus a. Now that you're multiplying the denominators, I'm going to put this in parentheses, times a squared plus 9a plus 18 is equal to a squared plus 18 is 6 times 3. So 6a plus 3a is 9a plus 18. Factor the a out. So a plus 6 plus 3 times a plus 6, a plus 3 times a plus 6. So we have a plus 3 times a plus 6. Cancel all common factors, if any. So a minus 5, 5 minus a, remember, when you cancel these two, you don't get a 1, but you get a negative 1. So this gives